Hi friends, let us understand one very important theorem. This is called intermediate theorem, intermediate value theorem, and this theorem is actually very intuitive, very easy to understand. Okay, so let us say we have a function. We have function that is defined on a closed interval a to b. That means it is defined at a also, it is defined at b also. Okay, whatever is the function. And this is a continuous function on this closed interval. Okay, this is a continuous function means there are no breaks. It's always continuous. There are no breaks in this function. It is defined for all the ones between a and b, including a and b. Now, if y naught, y0 is any value between fa and fb, there is a y0 which is between this and this. Let's say, for example, this is 2 and this is 4, and y0 can be 2.2, 2.6, 3.9, whatever. Okay, then y0 equal to f of c for some c in AB. Between this a and b, let's say this is 1 and this is 3, then there will be some c between this, between 1 and 3, where, where if you want for whatever value between 2 and 4. For example, if you find 2.2, then there will be some c between 1 and 3 which will give this value of 2.2, right? Or 2.4 or 3.9, whatever. So basically, what we are saying, this function is different from 1 to 3 and it is taking a value from 2 to 4. Okay, then what I are saying, because it is continuous, whatever value you want between 2 and 4, there will always be some value here between 1 and 3 on the x-axis that will give this value, uh, 2 to 4, right? So this is very intuitive, right? Because this is continuous. In the continuous, it means the worst case, it has to go like this, right? Even if you directly join this, then also it will cover all the points between here to here, right? All the points here to here. It will at least cover once. For example, it can cover multiple times also. You can go like this, right? Or you can go like this, up and down, like this. Probably it can cover some points below f of a also, or above f of b also, right? So, for example, in this case, it is covering some points below f of a and some points above f of b. But in the worst case also, it has to cover all the points between f of a and f of b, right? In the worst case, because it is continuous. There is no way you can skip any point between f of a and f of b. It can cover more, but definitely it has to cover all the ones between these two items. That's what we are saying. There is a value, um, f of a and b, then y not equal to f of c, right? If y not is any value between f of a and f of b, whatever value that you pick between f of a and f of b, there will always be some c that will give us this value. F of c will be this y naught. There will always be some c which is between this and this. This is very intuitive, right? If this is continuous, this point and this point you are connecting with a continuous line, obviously that line or that cover, it has to go through this entire range, through this all these points. That's what we are trying to say. So here, two things that we have to note. This AB, both are closed intervals. Closed intervals are important. It has to be defined here also, here also. For example, if it is not a closed interval, if it is an open interval, let's say I define some function like 1 by x. 1 by x, then it goes like this, right? 1 by x, it goes like this. Then you cannot say, you cannot take a and b as 0 and 5, right? Because at 0, it is not exactly defined. Because, for example, what we are trying to say is, if a it is an open interval, then f of a is not defined, right? F of a is not clear. So that's why it has to be a closed interval. If it is not closed interval, then f of a we cannot clearly say. For example, if you are taking a function like 1 by x, then f of 0 we cannot define, right? It goes to infinity, right? So that's why this closed interval is important. It has to be defined at a also. There has to be a value. It has to be defined at b also. And it has to be defined throughout the line. And here we are talking about the ones which are between f of a and f of b. We are not talking anything beyond f of b or below f of a, because that we cannot ensure. We cannot ensure that this curve will go down and go up. We can only ensure that this curve will cover this entire area at least once. It can cover twice or thrice, it doesn't matter, but it will at least cover once. That's what we are trying to say. This is the intermediate value theorem. Now, this theorem, you use it multiple places. It's a very, very important theorem, right? Let us take one example. Okay, how do we use this? We are given this equation x cube minus 15x plus 1 equal to 0. Then we have to show that this equation has three solutions in this interval minus 4 to 4. One way is to draw this graph and then see whether this graph is touching x-axis at three different points or not. Okay, at three different points, and all those 3 points are between minus 4 and 4. And another way is to solve this equation and find out what are the values of x and then find whether they are minus 4 and between minus 4 and 4. But this is not a quadratic equation, so it will be slightly tricky to solve. So instead, what we do, we'll use the intermediate value theorem. We'll say f of minus 4. What is f of minus 4? Minus 4 cube minus 15 into minus 4 plus 1. This is minus 64 plus 60 plus 1. Right. This is equal to minus 3. Right. Minus 64 plus 60 plus 1. Okay. So what does that mean? At when x equal to minus 4, this function is negative. X equal to minus 4. And let's say f of minus 1 now. F of minus what is it? This is minus 1. Minus 15 into minus 1 plus 1. This means minus 1 plus 15 plus 1. This is equal to 15. That means f of 1, f of minus 1, this is equal to some 15. This is somewhere here. Okay, what does that mean? So f of minus 1, f of minus 4 is minus 3 and f of minus 1 is 15. As per your intermediate value theorem, here f of a, this is negative and f of b is positive. So there should be some c which will give all the values which are there in between. Okay, so there should be some c, some x coordinate that should give that should give all the values between minus 1 or minus 3 and 15. There should be some c. That means there should be some c, some value in between which is giving f of that c should be equal to 0 between minus 4 and minus 1, between these 2 points, because between these 2 points minus 4, that is minus 4, x is minus 4, that means f of minus 4 is minus 3. This y coordinate is minus 3 and this f of minus 1 is this. So for there should be some, definitely some c which will give in between, all the values in between. What are the values in between? Minus 3 to 15. Minus 3 to 15, what are values that we want? There should be some value of c, some x that will be there. So definitely there is a root between minus 3 and 15, because at that place, whatever is that c, f of c will be equal to 0, and that 0 is between minus 3 and 15. Basically, what we are trying to say is the graph is negative at some point, the graph is positive at some point. So obviously, and the graph is continuous because all polynomials are continuous. It has to cross x-axis at some point, right? At some point between this minus 1 and this minus 4 and plus 1. If x is minus 4, x is minus 1. Minus between minus 4 and minus 1, this graph has to cross x-axis at some point. Okay, that's what we are trying to say. Now let us take f of 1. What is f of 1? This is 1 cube minus 15 into 1 plus 1. This is minus 15. F of 1 is again negative. F of 1 is negative somewhere here. What does that mean? F of minus 1 is positive. F of 1 is negative. What does that mean? There should be some value between minus 1 and plus 1 between in this point where f of x should be 0, because it is negative to the at minus 1 and it is it is positive at minus 1, the function, and it is negative at plus 1. So obviously there should be some value between minus 1 and 1 where the function is actually equal to 0, or the function is actually equal to any item between plus 15 and minus 15, right? Even if you want 14, there would be some x. You want 12, there would be some x. You want minus 10, there would be some x, right? Now again, f of 4. What is f of 4? 4 cube is 16 minus 15, sorry, 4 cube is 64. 64 minus 15 is 460 plus 1, which is equal to 5. This is again positive. Right? F of 4 is again positive. So what does that mean? Between 1 and between 1 and 4, there is again one more root because it is going from negative to positive. It will cross x-axis once more, definitely. So what we are saying, between minus 4, minus 1, plus 1 and plus 4, it is crossing once here, once here, once here. So there will be definitely 3 roots. Right, guys? So this is a simple application. What we are this is an extended version of intermediate value theorem. One is negative, another is positive. Obviously, that means the curve has to cross 0. Right? Intermediate value theorem is more generalized version, which is a more generalized version. Right? We are using the specific case where one is negative, another is positive. That means there has to be a root. Okay. Now that we are talking about roots, let us look at these statements. In fact, they are very similar. In fact, they are exactly same. Find the roots of this equation. What does that mean? This equation when it is crossing x-axis. What does this statement mean? Whenever it is crossing x-axis. That's the roots. Find the x coordinates of the point where the curve y equal to x cube crossing the line y equal to 3x plus 1. What does that mean? Crossing the line. That means at that point, both y and x and y should be equal. That should be equal to x cube is equal to 3x plus 1. We have to solve this equation. What does this mean? This again equals to x cube minus 3x minus 1 equal to 0. This is equal to this. Find all the values of x for which x cube minus 3x equal to 1. Again, this is equal to this. Right. What does that mean? X cube minus 3x minus 1 should be equal to 0. We can say the same statement in multiple ways. Find the x coordinates of the point where the cubic curve x cube minus 3x, that is the curve, crosses the line y equal to 1. What does that mean? At that point, xy, or for some particular point xy, x cube minus 3h should be equal to 1. Because y should be same, x should be same, and what is this x? That means again x cube minus 3x minus 1 should be equal to 0. Solve the equation of this. This is nothing but finding roots of this equation. Okay, if you have to see all of this graphically. Okay, so this blue line, this is x cube. That is, blue is x cube. Okay, and this orange, what is orange? Orange is a straight line. That is, orange is 3x plus 1. 3x plus 1. And what we have? Then we have x cube minus 3x minus 1. F of x cube minus 3x minus 1. This is green. This is this one, x cube minus 3x minus 1. Okay. And what we are saying? Find the roots of this equation x cube minus 3x minus 1. What does that mean? When this green line is touching x-axis. Okay. That is this point. 1, 2, 3. Right. These are the 3 points. Now, that is what that is the first statement. When are the x's? What are the x's for which the roots of this equation? That means when it is touching x-axis at the same as this one. This is also same. Find the x coordinates of the point where the curve y equal to x cube crossing the line y equal to 3x plus 1. Y equal to x cube, that is this point. Right. This blue line is touching this orange line. Orange line is the 3x plus 1. This blue line and this orange line when they are crossing. Right. So these are those 3 points. This point is corresponding to this root. This point is corresponding to this root again. The green line is touching x-axis here at the same point. The blue line is crossing this orange line. Similarly here, this blue line is crossing orange line. At that point, this green line is touching x-axis. Similarly, this one, this blue line is crossing orange line. At that point, this green line is touching x-axis. Right. That is this one. Find the coordinates when the curve is crossing this one. This we have figured out. Find all the values of x for which x cube minus 3x is equal to 1. What is x cube minus 3x? If you take this f of x plus 1 is equal to x cube minus 3x. Right, f of x plus 1 is equal to x cube minus 3x, because it is minus 1. If we do plus minus, then we will get this one. So what does that mean? This f of x, if you shift 1 unit upwards, f of x plus c, f of x plus 1. That means if you shift 1 unit upwards, that is this black graph. Okay, x cube minus 3x is black. This black graph. Now what we are saying, for which find out x cube minus 3x is equal to 1. When is this 1? Those are all the values. Right. So clearly this is 1 point. That is this root. And here again it is 1. That is this point. And here again it is 1. That is this point. So this point, and this point. At these three places, this graph is equal to 1. What does that mean? This green graph is equal to 0, because this graph is actually shifted 1 unit upwards. Whenever green is 0, the black is 1. Whenever green is 0, black is 1. Whenever green is 1, black should be 2. Right? So the graph is always 1 unit upwards above the green one. Right, guys? So all the statements are actually the same statements. And whenever we are talking about the roots, when we say one, the line is the point is negative and the another point is positive, there should be a root in between. That means we are talking about intermediate value theorem. Right? That is actually about intermediate value theorem. Intermediate value theorem gives us the liberty to say such things, that if f of a is negative and f of b is positive, there is a root between a and b. Right, guys? Hope you like this. Thank you.